All righty. We are moving on. No, I told you we're going to do stuff with those pages extra, and then we're going to check them all at the same time. It's almost like I didn't even say that. All right. So yesterday we spoke of the surface area of something. Surface area of something, three-dimensional object, take it, dip it in paint. The paint only covers the outside, yes? If I were to cut this in half, would there be any paint on any of these pages? No, because those pages are where? Inside. They are not part of the surface, yes? Now, because surface area only cares about the faces on the outside, we continue to measure it in how many dimensions? 2. Even though it's a three-dimensional object, each face of that three-dimensional object is only a two-dimensional shape. Excellent. Volume deals with the amount of space an object contains. So we are talking about how much space the object takes up in the universe, which means we must worry about how many dimensions. 3. 1, 2, 3. Alrighty? Now, we use the word volume to also synonymously mean capacity. Those are two different things. Right? Pretend that this is not a textbook. It is just a rectangular prism. Yeah? What would happen if I were to pour my coffee right there? What would happen? You've seen me draw straight lines. How stable are my hands? Again, what would happen if I poured coffee right there? It would spill all over the place. Why? That coffee is falling through the universe and hitting this. This is in the way, yes? Because this is taking up that amount of space in the universe. Right? This has a volume. The coffee has a volume. They cannot take up the same amount of space. Everybody agree? That is the difference between volume and capacity. If I were to take and cut out, remember these aren't pages, pretend this is a box, and take this lid off, could I fill it with coffee? Yes. That would be its capacity. Does everybody understand? Now, is capacity equal to volume? No, it is slightly smaller. Why? Jordy.
Well, because the volume is the whole book, but there's the border.
There you go. That's what I'm looking for. If you fill up, for example, a measuring cup, the measuring cup has a volume that it takes up in the universe, yes? Now, technically, it's actually quite a bit smaller because the measuring cup's hollow, yeah? But even if I put a lid on the measuring cup, it would take up a volume, yes? And that volume might be however many cubic centimeters or inches or whatever I'm measuring it in, yes? If I were to fill that cup with that amount of liquid, it would overflow. Why? Because the cup itself has volume and the capacity is slightly less than. Everybody cool? All right. So, now we need to talk about how all pyramids and prisms are created. You already know this, yes? What is a prism? We have a definition of it from 5 pages ago. You shouldn't need to turn back. What's a prism?
Prism is two parallel faces that are connected by a rectangle.
Excellent. So a prism starts with a two-dimensional shape, yes?
Yes.
All right. Right now, how many dimensions does this have? You can only see 2. In reality, how many does it have? 3, because it does have some depth, doesn't it? We all agree, right? Okay. But right now, all you can see is this, yes? Now, if I continue to add layers of that rectangle, what will I eventually get? A rectangular prism with a discernible depth. Does everyone agree? So all a prism is a two-dimensional shape with 2 dimensions, length and width, repeated backwards or up or diagonally until it gets to the other face. Does everybody understand? Excellent. So, what is this particular piece of paper right now? You have no measurements of this paper, yes? So, how much space in the universe would you say this paper is taking up? Remember, you can't say a number right now about the paper because you haven't measured it. It is taking up a certain amount of space. 1 sheet of paper's worth in the universe, yes? So the volume of this is 1. Does everyone agree? If our units are pieces of paper. Does everyone agree? So it is 1 piece of paper cubed, 1 pp cubed. Everybody agree? All right. What happens if I now start to make it a prism? Now what's its volume? Now what's its volume? What if I put 500 pieces of paper? What's its volume? 500 pieces of paper. How do you know? Right. If I start with 1 shape and I repeat it, I get a volume, yes? That's it. That's how we work out volume. That way, it doesn't matter what shape we are dealing with, okay? Here is what I mean by that. Volume is simply the base area times the height. Always. It doesn't matter what. Now, this is where it gets weird. All right? So, the example I'll use is the example I just did. 1 sheet of paper. Is 1 pp cubed, right? Piece of paper cubed. That's its volume, yes? Now, if I repeat that sheet, I get a prism. That would be 1 pp cubed times however many sheets. Is everybody cool? Now, let's give you some measurements. This piece of paper, of which you can only see how many dimensions? 2, because you cannot see this one because I am showing you just this side. Does everyone agree? This piece of paper is 11 inches by 8.5 inches. Everybody cool? All right. So how could you tell me that area? What is it? Length times width, of course. What is it? 93 inches squared. Agreed? Okay. So now, you're smart kids. 93 inches squared. What's this one? 93 inches squared. What's this one? 93 inches squared. Does everyone agree? Okay. Now, how many times have I repeated it? 3 times. So right now, the volume of this prism is 93 inches squared times what? 3. Everybody cool? All right. Now, that's not really how it works, but that is the thinking that goes behind what we are doing. Is everybody comfortable with me, what I am saying? All right. Now, the reason that's not really how it works is because, yes, this is 3 papers, but it is not 93 times 3, is it? Because this distance is not 3 inches, is it? Right? Everybody cool? Okay. So, that's what we do. Now we got to talk about why this confuses kids. What is wrong with that term? Because that's the term that is used. Area of the base or base area. What is wrong with that term? What causes you guys to screw up?
We always think the base is on the bottom.
Always think the base is on the bottom. In reality, what is the base? Base is the repeated shape. All right? So in this case, it's a rectangle, yes? So to find the base area, I would do length times width, wouldn't I? Everyone agree? Okay. Sounded like a duck back there. So, when it was this, the base area was what? And how did we find that? Length times width. And then we would have counted how many times it went back. Yes? Right? We used 3 because it was 3 pieces of paper. But of course, we can't do it that way because the 3 back is not a measurement. Right? All right. Everybody cool? All right. What if I start with that shape? What will I do? Base times height, multiply. That would give me this base area, yes? Because this is a triangle. Agreed? Okay. What if I gave you... Pretend it's not all folded. What's that? What can you see? Just a circle. So how would you do this volume? Pi r squared times what? Pi r squared is the base area times what? However many times it repeats. All right? Whatever the base area is, the repeated shape might be a circle, might be a rectangle, might be a triangle, might be something weird. Yes? Might be this shape. That could repeat, couldn't it? So, tell me how you would find that volume. What would you have to do? You would have to find the base area. What's the base area? This weird shape right here, right? You could cut it right there. There is a formula for trapezoids. I haven't given it to you. But if you found it, you would find that one, add them together, and that would give you your base area, wouldn't it? And then what would you multiply it by? How many times it repeated? Where is the repetition? That way. Right? So what does that make this? That is the height. Why? Because where does height go from the base? Away perpendicularly, regardless of orientation. Does everybody understand? My height is feet to head. End of discussion. Even if I'm leaning against a wall. My base is still my feet, and height goes 90 degrees away from that. Yeah? So, base is the repeated shape, and height is the direction of repetition. The direction it goes away. Everybody good? Now, return to the previous 5 questions and do the volume. The previous 5 questions I'm speaking of are not the ones on page 227 and 228. They're back here on 224. Remember how I told you to save some space? So, the first one is a rectangular prism, yes? So what is the base shape? A rectangle. Since they're all rectangles, does it matter which one I choose as the base area? No. What color do you want to use? Blue? No problem. We said that the blue was 40 by 8, yes? So the volume of every single prism is base area times the height. Well, the base area, somebody, I didn't know who it was, said they want to make the blue one the base. So what's the area of that blue rectangle? It's 40 times 8, right? And then if that makes that the base, the height is the direction away from the base, which must be 24. Now the prisms are super easy, rectangular prisms, because it's just length times width times height. You already knew that from back in the day, right? But I didn't want to say that formula because everybody gets stuck on that formula when we change shapes. This one always works. Everybody cool? So, 40 times 8 is 320. 320 times 24? 7,680 watts. Centimeters cubed. Because there are 3 dimensions. Everybody cool? All right. Now, does that mean I could fill that box with exactly 7,680 centimeters cubed? No, because that box will have a very slight bit of volume. Its capacity is very slightly less. Does everyone understand? Okay. Now, well, let's talk about pyramids. How does a pyramid relate to a prism? Let me show you what I mean. 8, 8. Let's keep it a square on the bottom. If I want to make a prism here, what must I do with this square? Nika.
Make it smaller until it reaches to.
If I want a prism,
Oh, prism? Oh, you just.
I just go straight up, right?
Yeah.
So I would go up, 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 and I would have a prism, yes? Now, the way I have drawn that, I repeated the shape at the bottom, yes? And what is that area? 64. Can you tell me the volume right now? No, why not? Because you don't have a height. What if I told you the height was h? What would the volume of this thing be? 64h units cubed. Agreed? Everyone understands that, yes? Okay. So, if I told you that volume was, or that height was 10, what would its volume be? 640, let's say centimeters cubed. Just keep it easy. Everybody cool? How does this, what I've actually drawn, differ from a pyramid? Now, Nika.
A pyramid is like repeating this more.
I would still start here, and I'd still have 8 by 8, wouldn't I? But it would go up to a point, yes? What is all of this space now? You have to think three-dimensionally. I'll erase the black. Now, nope. It's empty space, isn't it? Right? Now, I've already told you that the volume of every prism is area of the base times the height, yes? A pyramid starts from the same base, yes? So what must a pyramid's volume start with? Area of the base again, right? That makes sense. But if I multiply it by the height, which is still 10, that's not right, is it? Because there's a bunch of empty space in there. Yes? Through experimentation, and what do I mean by experimentation? Yeah. It has been determined that a pyramid and a prism that share the same base and the same height are exactly, the pyramid is 1/3 of the volume of its related prism. Now, when we write it this way, 1/3 times area of base times height, there's a fraction there, and that makes most of you lose your bladder control. So you can also write it as area of base times height divided by 3. Whatever way works better for you. So here we are. We've got our area of the base. So we know that a pyramid is 1/3 of its related prism. And we know 1/3, every prism is area of base times the height. And 1/3, since this is a square-based pyramid, the area of the base is length times width. But it's a square, so they're the same. But I'm going to write it out. 32 by 32 by the height, 65. And then you would just punch that into your calculator. Now, to punch it into your calculator, if your calculator doesn't have fractions, what's the best way to punch this in? The best way to punch it in is that divided by 3. Tell me what the answer is.
22,186.666
Feet cubed. Is everybody cool? Yeah? Area base times the height. No matter what the base is, we just multiply it by the height. That gets our volume. If it's a pyramid, we then divide it by 3. Easy, right? So let's go to the next one. Number 3. Most of you, we don't have a lot of room left for the cone, yeah? So I'm going to go ahead, and remember how I left you that whole last page? I'm going to split that in half. I'll do cone over here and cylinder over here. Now we remember, nice spelling, cylinder. Cylinder. The cone was radius 15, height of 12. So the cone would have looked like this. 15. Height of 12. Now, this is another thing that trips you young folks up. In surface area, did I need the height? No, I needed the slant height. In volume, do I need the slant height? No, in volume, I need the height. Okay? So that's the first warning right here. Volume of prisms, not prisms, volume of pyramids needs height, not slant height. Okay? That's the first warning. Now, other than that, it's exactly the same. Is a cone a pyramid? Yes, because it starts with a circle. The circle repeats. It gets smaller and smaller and smaller. Yes? So does the cone relate to a prism. Yes, the prism it relates to is a cylinder, which is a circular prism, right? So, the volume of the cone, just like all pyramids, is 1/3 of its related prism. Yes? So it's 1/3 of a prism, which is area of base times the height. 1/3. What is the base of a cone? A circle. So it's a circle area times the height. And what finds us the area of a circle? No. Of a circle.
Oh, a circle.
Pi r squared. Yeah. Give me a pi, apple. R squared h. Right? And then we would just punch into our calculator. Would we use the pi button? If we wanted a real life number. Would we just do it in our heads if we didn't? Yeah. Or if the numbers are too big, we wouldn't use our head, right? So, of course, this two ways. Real life is going to be pi button times what? Oh, wait, we should write it out. It's 1/3 pi times 5 squared times, 15 squared. 15 squared times, the height was 12 or 22? I can't even read my 12. Now, in real life, we would punch pi times 5. Then we'd probably hit the x squared button. Then times 12. Then equals. Then divided by 3. And what is it? For IRL? 900. No. Real life. Because that's what everybody wants to do. I try to get kids to use pi, and they all put the decimal anyway. No matter how many times I say, I want you to use pi, I want your next teachers will want you to use pi, your university teachers will want you to use pi, all kids always put the decimal. Until you now, Shitu, just told it to me with pi. Thanks. What is it? 314.15, blah, who cares? Centimeters cubed. Yeah? Now, what is it in math class? What's 15 squared? 225. What's 225 times 12? Use your calculator if you need to. 2,700, right? What's that divided by 3? So the answer in math class is 900 pies, which is what Shitu just told me. Everybody understand? Which way causes me less hassle? 900 pi, because then I never have to listen to how many decimals, which is a question I hate. All right? Everybody cool? Okay. Now let's look at a cylinder. Is a cylinder a pyramid or a prism? Prism. So, what's the volume of a cylinder? Same thing as all prisms. Area of the base times what? Height. Do I need to worry about dividing anything anywhere? No, because it's a prism. So a cylinder, what's the area of the base? It's a circle times the height. What's the area of a circle? Pi r squared times the height. Now, our cylinder, we have it right on this page. Its height is 20 centimeters and its diameter is 10. So its height is 20, its diameter is 10. What's the problem? We need a radius. So what's its radius? 5. So all I do is I put that in here. Pi times, what's r? 5 squared times height, 20. Yeah? let's finish up the math way. What's 5 squared? What's 25 times 20? 500. 500 pi. Done. That's where I want you to stop in math class. Of course, IRL, you would use the pi button, and you would get, of course, you wouldn't punch this all in with the pi button, would you? You would only punch that in with the pi button, because that's way easier to get. And from there, you would do 500 times the pi button and get an answer. But before you ever punched it in, you would say to yourself, self, it's got to be around 1500, doesn't it? So what is it? Point blah, I don't care. Okay? Does everybody understand? Now remember, this is key. Do either one, oh, sorry, I highlighted the wrong one there. Do either one of these specify the shape of the base? No, they do not. As long as it repeats, it's the base area. Does everybody understand what I am saying? Good. So now I'm going to shut up and you're going to do some work. On this page that you have a bunch of surface areas, I want the volume of B. Start writing this down. I want the volume of D. Yes, Sam. And I want the volume of E, F, and G. Go. B, D, E, F, G. And then we're going to go over all of this before lunch.